Okay. I think we can probably go ahead and get started if you're ready.
Sure.
Okay, cool. That way it'll be exactly at 10:03. So thank you everybody for logging into this ANR hour this week or this day. My name is Melissa Mitzi. I'm the Fulton County ANR agent in Northwest District, and I'll be moderating today. We've got Dr. Blaauw here, and he is our stone fruit specialist, plus a lot of other fruits, just general fruit questions. And today we're going over some significant small pests that we may see this year and stuff to prep for in our significant fruit crops. So before we begin, just a couple of housekeeping tips. I will be keeping tabs on the chat box. If I don't get to your question immediately, don't panic. I'm just kind of waiting for a little pause so I don't cut Dr. Blaauw off. But feel free to ask your questions in the chat box. And then we will go from there just to keep it a little bit more orderly. And we'll also have time for more generic questions at the end as well as and some discussion. And maybe you can give Dr. Blaauw some feedback on some problems that you're encountering in your county. This will be archived and it will be sent out to agents across the state. So with that, can everybody hear me? Can you type in the chat box that you can hear me, or if you are having problems? So I know you're there. Awesome, Kim, cool. Okay, awesome. So that means everything's good on our end. So without further ado, I'm gonna give it over to Brett.
All right, let's see if this works. Showing up?
Yep.
Perfect. All right, well, thank you, Melissa, for having me, and everyone who's watching this live and everyone who watches the recording. So today, we're really going to cover just some current and emerging fruit pests in Georgia. Just to kind of, oh, no, it's not, there we go. Melissa already introduced me, but note that my main crops that I cover are peaches, apples, and grapes. So today I'm going to try to cover some of the key and potential emerging pests that will attack not necessarily all these crops, but give you some examples of each of these three main crops here. So we'll first start off with two of our pretty big current pests, the San Jose scale, which attacks both peaches and apples, and the spotted wing Drosophila, which attacks basically all small fruits, but the small fruits that I cover are mainly grapes. So I'll be looking at grapes there. And then two emerging pests, brown marmorated stink bugs, which have been here for a while, but they're really only becoming problematic within the past couple of years. And I think they're only going to get worse within the next few years. So I'm still considering them an emerging pest. And then spotted lanternfly, which actually isn't in Georgia yet, but it's definitely something we need to look out for. So I'll cover that in a little bit of detail later. And then if I have time, because there's a lot of stuff to cover, I want to talk about the My IPM smartphone app, which hopefully people already have heard about. But if you haven't, then you'll learn something new today, and then you can go and download that. All right, let's start off with San Jose scale on peaches and apples. So San Jose scale are just these tiny little insects. You can see up here in this picture, all these little round things are scale, and they're covered with a protective covering. It's really this waxy layer that helps them be protected from the elements, but also protected from insecticides. So they are really hard to kill, and then they can start out with just a few of these insects and explode into a mass number of them spreading across a plant. The females can produce about 300 offspring, so just having one female can quickly spread across a limb, then with over time can spread across a whole tree, causing problems. So you can first see some issues with leaf chlorosis, then that will lead to twig and limb dieback, and eventually if it gets out of control, you can start to actually see some tree death at the high populations. And these little yellow things over here are the crawlers. Those are the immatures. They're only really crawling for probably a couple days, and then they settle down and start to secrete that waxy layer, and that's when they become protected. So they're really only vulnerable for about 48 hours, unfortunately. So that they can even move to the fruit and they cause these measle-like lesions, which I'll show here. This is a crawler that has just started to secrete that waxy layer, and it's now covered up with a little protection, but it's on the peach skin. It's on the fruit skin right here, and this causes this little, we call it the measle-like issue here. But then if you look at on the bigger picture of this whole peach, all these little white dots are the scale, and then all those little red round rings are those lesions that they cause. So it doesn't cause problems to the actual flesh of the fruit. It's really a cosmetic issue, but it's something that a consumer is not going to want to buy. That looks like a pretty gross peach, even though it will taste just fine, but the consumers don't want it. And the bigger issue is actually that if you're getting scale on the peaches, they're actually hurting the tree even more. You can get it on apples as well. So all these little dark rings are the San Jose scale underneath your coverings. They cause a similar lesion on the apple skin as well. So that's another apple that people probably won't want to eat. So the problem, really, besides just ugly fruit, has been a huge issue since the 1800s when it was introduced into the United States. But for decades, we were able to control it pretty effectively with methylparathion. Methylparathion on its own is a pretty nasty chemical, so I'm not surprised that in the 1990s that it was banned by the EPA. But unfortunately, after that ban, a lot of our tree fruit growers switched to using a pyrethroid-based management program for insects in general. Pyrethroids, unfortunately, don't have any real efficacy against scale, but they also have really good efficacy against a lot of our natural enemies that would otherwise be feeding on scale. So our non-targets are being killed that would naturally control scale, which allows our scale pressure to resurge and become even worse than it was. And we currently manage scale with our horticultural oils. They work reasonably well, but it kills primarily through suffocation. So you really need to have thorough coverage in order to get really good management. And unfortunately, that's not always easy to do. And because of that, and because of our pyrethroid use, we're seeing only worsening cases in terms of our scale population, with limbs and even trees dying because of this insect. So really, it comes down to is what are our options? So currently, we're doing our dormant sprays and our delayed dormant sprays. With our dormant sprays, again, thorough coverage is critical. So using high volume and slow speeds. This will be applied either fall or winter, but definitely post defoliation of the trees. And the dormant sprays are really only recommended for our peaches. And so we can add in, the main one would be just this dormant oil, about 2 to 4% per volume. You could also add in a couple other insecticides to help increase the efficacy of that. But it's not necessary. We're still getting pretty good control with the dormant oil at our dormant timing. Delayed dormant, which is going to be later in the season, is going to be a pre-bud swell in our peach and green tip in apple, so about early spring. And post-pruning is ideal to get that thorough coverage, and I'll talk about that in a little bit. But here, again, we want to use our dormant oil. Apple is a little bit higher, about 2 to 3%. But in peach, we want to keep it pretty low, about 0.75 to 1.5% per volume when applying those horticultural oils. And here, we can also add in a couple other insecticides. And it's definitely recommended at this timing to add in something else because it will increase your efficacy. Lorsban on there has the longest residual, so if you apply that with your oil, it's going to last longer in terms of actually managing the scale. But it's also a nasty chemical, and there's an inevitable ban of that. It's in the EPA kind of regulatory system right now, whether or not to ban it. So it's something that we shouldn't really rely on, but right now it is probably our best option at this timing. So coming back to our coverage issue, we're seeing this increase in scale, and growers are doing both these dormant sprays and delayed dormant sprays, but we're not getting the control that we want. So I went back and looked at what can we do to increase that. So went to our delayed dormant application using 1.5% oil, looked at 2 timings using our pre-pruning and post-pruning. timing. So basically the same time of year, but trying to get that oil out there either before the trees have been pruned or after the trees have been pruned to see whether or not by removing those extra limbs, are we going to get better coverage? And then looked at volume. So 100 gallons per acre is basically our typical management for peaches and apples. 200 gallons per acre is what we recommend for scale. And then 400 gallons per acre is this kind of reach for the clouds, trying to get everything covered. It's really not ideal or even logistically possible for most growers, but we're just going to throw it in there to see what happens. And we used water-sensitive spray cars to see what our coverage was. So we set up, I have our pre-pruned trees and our post-pruned trees, went out there and sprayed. And what we saw is that at 100 gallons, if we increase it to 200 and 400, you see an overall increasing of coverage on these cards. But when we look at the not pruned or the pre-pruned, which are the dark red versus the post-pruned or the pruned, in the pink, at 100 gallons per acre, we're seeing a significant increase in coverage, over 25% increase in coverage of those cards just by pruning off some of those extra limbs. We're seeing a little less increase, about 20% in our 200 gallons per acre, and then a little over 10%, about 14% increase in our 400 gallons per acre. It's not significant, but you're still seeing a little bit better coverage by adding 400 gallons per acre, but you're not really seeing a big difference between the 200 and 400. So the big real jump is going from 100 gallons to 200 gallons. You are going to get better coverage. But the bigger picture here is by pruning your trees, you're going to get the best coverage. So even at 100 gallons per acre, you're significantly increasing the coverage by pruning your trees first. But what we're really concerned with are the scale. So what's going on with the scale? So we also monitored crawlers. So those are the immature stage. We can actually put out these little tapes to see what's going on with the scale. And we saw a similar picture. At 100 gallons per acre, there was a significant decrease in the number of scale once we pruned the tree. So if we had a pruned tree, we increased the coverage, we decreased the amount of scale on that tree. You saw the same trend for 200 gallons per acre and 400 gallons per acre. The decrease was only significant at 100 gallons per acre. So really what this is showing is that at 100 gallons per acre, if you have not pruned your trees, you're not getting enough coverage to actually effectively manage the scale. Well, at 200 gallons per acre and 400 gallons per acre, pruning the tree actually does increase the coverage, but you're not seeing a significant increase in the management. So at 200 gallons per acre, you could probably get away with not pruning and still get effective management. So what we're seeing is by here increasing our coverage here on x-axis, we're actually decreasing the number of crawlers on our tape, just basically showing you a nice kind of obvious of what we would expect, that increasing coverage decreases our scale, which means we are increasing our management. So it's good control. Unfortunately, we can't kill them all with oil, so we want to refine our management timing throughout the season. So really just monitoring the scale to best time our other insecticide applications. And so there are ways to do this. They're a little bit tedious. So using pheromone-baited sticky cards to look for the males, and then you can check the phenology model, which I'm not recommending many people do this because it is really time-consuming and doesn't always work. But looking at this phenology model is really good to know. So the scale are really only active or developing between 51 degrees and 90 degrees as its upper thresholds. And using those, you can really accurately time when the insects are going to be out there. So the going phenology model right now is using this 51 degrees lower and 90 degrees upper thresholds. And at 600 degree days after capturing males on those pheromone sticky cards is when we're going to start seeing a peak activity of the scale crawlers. And that's when they're most vulnerable, so we can get the most bang for a buck for an insecticide application. But it's also, again, like it's not very time effective, it's really tedious, and you have to make sure you're checking those sticky cards almost on a daily basis to know when the males are active. So you can also monitor for the scale crawlers, and once you start to see an increase in activity, then you can know that you're probably getting close to a peak and you can apply insecticides there. But what I want to know is whether or not we can take the best of both worlds. Can we use that phenology model, using those upper and lower thresholds? Can we find a degree day timing just for the crawlers? So using our timing of degree days after February 1st, we can go on the UGA weather model, and under the calculator, we can calculate the degree days using these thresholds in February 1st. And actually find a really good timing. So I developed this by looking at the scale activity using this black electrical tape wrapped around a limb here, and then you take double-sided tape, just like the 3M scrapbooking tape, wrap that around the electrical tape, and it creates a little track. And you can go on there on a weekly basis and count the number of scale, and it's hopefully it'll start off low. Hopefully it doesn't increase, but it can increase to be pretty much an insane number, as you can see in this lower picture and up close. All these little yellowish orange things are scale crawlers. So we see that, we know it's time to spray. So what this has come down to is using the past 2 years of data, we see that there are 3 main peaks of activity. So there's 3 good timings to target the insect when it's at its most vulnerable stage. The first timing is about 700 to 800 degree days after February 1st. And this is a pretty good timing to target that early generation. And hopefully if we get good coverage and good management early on, we won't see these other peaks later. But if we're still having problems in these orchards, we can come back later about 2,000 to 2,400 degree days. And then for our final peak, which is also the largest peak, is about 3,400 to 3,600 degree days after February 1st. And so if we can target those timings, we can have better management of the scale. All right, so what can we use to manage those scale crawlers during the season? These are especially important for orchards with a history of scale problems, targeting those peak emergence. And apple, we have a couple, or one option that's not available in peach is diazinon. But for both peaches and apples, Movento, Esteem, and Centaur are both highly effective for managing scale within this season. Note that Movento must have substantial leaf area, so you still need to have new growth on the trees in order for the tree to uptake it. It's a systemic insecticide, so if you're spraying it on young trees or late in the season when there's no new growth, it's not going to work on crawler. So really, the best timing right now is really between May and June. But Esteem and Centaur is going to be targeting those crawlers. All right. So summary: the delayed dormant oil timing is critical. Thorough coverage is crucial. Better coverage equals better control, which is not surprising. And post pruning is important at low volume. So if you're unable to go to a high volume like 200 gallons per acre, doing 100 gallons per acre works as long as you're pruning the trees first before you're applying your oil. Adding in an insecticide can help, especially within season, and targeting those peak crawler activity points is going to be the best in terms of getting the best bang for your buck. All right, let's move on. Spotted-winged Drosophila and grapes. So spotted-winged Drosophila is bad news for most small fruits. And with grapes, it's no difference, except that with bunch grapes and like wine grapes, they are processed. So we're not as concerned with having larvae in the fruit, but we're concerned with some other issues, which I'll talk in 1 second, but let's introduce this pest. Males have these spots on the wings that give them their name, spotted-winged Drosophila. The females have the saw-like ovipositor, so that's the egg-laying device, and she's able to actually use this saw to cut into ripening fruit and lay their egg, whereas most Drosophilids will lay their eggs in rotting fruit. So they can just tear right into that because if the fruit's already broken or rotting, it's really easy to lay an egg. Whereas the female can get into that nice ripe fruit where it has still intact skin and lay the egg. And that's where the problem begins. The grapes become attractive at about 15 degrees Brix, so that gives us a good timing to know when those grapes are vulnerable. But and like I mentioned, the big problem is not that there's larvae in there. The problem is that it actually these flies can spread microbes. Because they can directly insert their ovipositor into the fruit, they're basically inoculating the fruit with these microbes and spreading disease. We have two major rots in grapes that can be spread by spider-wing Drosophila. First one is sour rot, the other one is botrytis, also known as gray mold. So we have our sour rot up here, gray mold down there. Both of these can reduce the yield and quality of the grapes. If you have something like this, you can't make wine out of rotting fruit. It's not going to be good, unfortunately. And both of these diseases are really problematic once you have berry damage. So either just natural cracks in the skin or mechanical from a sprayer or people going through the vineyard. Birds, other infections can cause diseases to get worse. But our problem here is insects. These flies can make both botrytis and sour rot worse. And so we're really going to focus on reducing the fruit injury, particularly by managing the flies so we can manage these rots. All right, so the previous research up in Cornell looked at oxidate and Mustang Max, so a fungicide and an insecticide coming together to target both our flies and our rots, and it decreased berry rot at harvest, so it worked. But using Mustang Max over and over can be a problem, and it's not ideal in our situation because oxidate works well, but our pressure down in the south is a lot worse than up in Cornell. So we decided to work with Kane Hickey and Phil Brandon to combine this previous research with pesticides and application with leaf pulling. So by leaf pulling, we were able to expose the clusters. So you can see in the picture, these clusters are nicely exposed. We still have plenty of leaves up above, but the clusters are exposed. That increases sunlight and airflow that can help decrease naturally the diseases, making it more airflow, less ideal for both the spider-wing Drosophila and the sour rot. But it also can allow us to increase and improve our spray coverage there. So in our leaf pulling, no leaf pulling versus our leaf pulling plus our pesticides. And here we use the Mustang Max like they did at Cornell, but we rotated that with Malathion and Delegate, which are both other good insecticides for spiderwing. But we also rotated them so we can hopefully fight some resistance, because we're already, unfortunately, up in the Northeast where they've been using Mustang Max a lot to manage spiderwing Drosophila, they're already seeing some resistance develop there. So what we saw is pretty awesome. We didn't see a ton of sour rot botrytis this year, or this is actually 2018. But what we did see was encouraging. Adding pesticides overall significantly reduced our rots compared to no pesticides. And when we added in that leaf removal, we did see the lowest amount of disease pressure that wasn't statistically significant. This was granted one site where we were able to see this, but we're repeating it this year in hopes of seeing some better results, getting more repetition, and hopefully really better results. Just to note that we can monitor for spiderwing Drosophila. If you're concerned, you can easily make your own trap. Here's the one that I made. It's just basically a big, you can use a solo cup or it's big plastic cups with holes punched in there. And using a 1 teaspoon dry yeast plus 4 teaspoon white sugar and 2 cups of water, plus unscented dish soap. So that unscented dish soap is important. It must be unscented, but a couple drops of unscented dish soap will remove the water tension, which allow, or the surface tension, which allow the flies to drown in there. And this picture is using old wine, which works well, but the dry yeast with the sugar is going to work the best. You can also buy commercial lures that work well. You're going to deploy those traps at veraison. And place the traps to the north side of the rows at around fruit level. So putting them near the fruit where the flies are naturally going to go will help attract them into your trap. Then you can see whether or not they're actually active in the vineyard. But more importantly, you can check the fruit. So this is going to indicate whether or not your sprays are actually effective for managing spiderwing Drosophila. So you can collect those intact fruits. So if it's a fruit that's already damaged, the larvae that are in there could be any sort of Drosophila fly, or it could be a whole bunch of different insects could be in there. But if it's an intact fruit, it's most likely going to be spotted wing Drosophila. So you're collecting the intact fruit, putting them in a baggie and adding a salt solution, a quarter cup of salt to 4 cups water. Basically wait for those larvae to emerge, and then you get these wiggly, gross little things coming out. If you have them, you know your spraying is not working, and you probably want to try something else. All right, a little summary. Overall, rots in 2018 were low in our Chardonnay, so we're going to repeat that again in 2019. See if we can get a little bit better results there. But what we did find in 2018 is that leaf removal decreased disease pressure. We saw the best when we added in those pesticides. The interaction was not significant, but the trend is there. It looks good. So the combination of leaf pulling and pesticides provided the lowest disease pressure. So it's really encouraging. We didn't get that significant interaction, but we're going to repeat it this year, and we're pretty sure it's going to be a really good process for managing both spotted wing Drosophila and rots. All right, let's get on to our emerging pests. First one is brown marmorated stink bug. But stink bugs in general feed on a wide array of wild and cultivated plants. And unfortunately, a lot of our fruits are preferred hosts of these stink bugs. They inject their salivary secretion into the plant when they're feeding, so they have these piercing, sucking mouth parts. They basically have a straw. They stick it into the fruit, release some of their saliva, which has enzymes that break down that fruit. Then they're able to slurp it back up, which sounds delicious if you're that bug, but it's pretty awful if you're that plant, because it's going to break down those plant tissues and cause some destructive damage by destroying those plant cells, which not only looks gross, but it doesn't really taste that good either. And it creates what we call cat face scarring. I wish it created this cute little cat face like this, but unfortunately it's more of something like this. It's this really dimpled, gross, enveloped peach that nobody wants to eat. And so they're highly mobile, so they can move throughout an orchard. They can move between different crops, and they actually will move between ripening crops. So if you have different varieties of peaches, as they ripen or harvest, they'll basically just move from one variety to the next variety, and just keep causing destruction. The first kind of injury that we see is from that piercing. When they pierce in, it causes the peach to ooze out. So it's almost like it's bleeding out here. So all this ooze is from feeding sites. But as that peach ages, those feeding sites become more of a dimple. And then if you cut into the fruit, into that dimple, you see this corking-like damage. And so that's going to be tough, and it's never going to ripen. And then when it gets older, it becomes that cat face. Similar injury in apples, you get all these little feeding sites. They don't bleed like a peach, but you get these little dimples there, and when you cut into the fruit, you see that corking again. All right, but the biggest concern here for our emerging pests are these brown marmorated stink bug. It's basically everywhere in the United States. It's been detected in 42 states. It feeds on over 100 hosts, and the biggest problem is that it's really disrupting their IPM programs. So a lot of growers up in the Mid-Atlantic and Northeast have had success with managing insects through IPM. So you're using mating disruption, using degree day timings for targeting pests. But once these bugs move in, both the adults and the nymphs feed on the fruit. They can be in the orchards all season long. Once you add in that new pest, you basically throw out the old IPM program. So right now, we're really trying to come back and develop new IPM programs that can target this pest. So a lot of that work has already been done in the Mid-Atlantic, which is awesome for us in the South, because it's being an emerging pest. We can use some of those results to help manage them now that they're a pest here. We have a native brown stink bug. It's basically ubiquitous out there. We can find it everywhere. It's right here, this brown stink bug. And it looks very similar to our brown marmorated, especially in the wild. Here, with the coloring, it's like pretty obvious, but in the wild, they look very similar. So some of the characteristics that distinguish the two is not this banding. They both have the banding on their abdomen, but if you look at the banding on their antennae, the brown stink bug doesn't. It has articulations, so it has these little elbows here. They're not actually banded. There's no coloration there. Whereas you look at the brown marmorated, you can see there's white bands at those articulations, and those are very distinctive for brown marmorated when comparing to the brown stink bug. Also, their shoulders. The native browns have a more pointy, more spiky shoulder compared to the rounded shoulders of the brown marmorated stink bugs. And if you want to impress your friends, you can collect both of these, and they smell different. Their stink is very unique to each of these species. The brown stink bug smells like cucumbers, at least to me. It's kind of fresh. It's kind of nice. The brown marmorated stink bug, on the other hand, is more of a coriander or cilantro smell, which smells a little bit more zesty. If you're into Mexican food, it could be really great. But they have a very unique odors, and so that's kind of fun party trick if you're a nerd like me. All right, so life cycle. Problem with these bugs is they love to overwinter in people's homes. It's a really nice protected spot for them. They come out in the spring. They move into our orchards or into our crops, and they start to breed, laying their eggs. The eggs hatch, and then there's 5 larval instars. They become adults, and they basically redo that cycle at least 2 times within the season. Then when fall comes, they move back into our homes and are protected until next year, where they come out and do it again. And what we're seeing through our monitoring is that it's pretty much getting worse with time here in the south. So what we can do is monitor. One thing is we can check for fruit for injuries, looking for those oozing spots early in the season on the small fruit. You probably have a problem. We also have pheromone-baited traps. You can use either a pyramid trap, which you can buy online, or you can buy these sticky cards. But both of them, you're going to need a pheromone, which you can buy. There's several commercially available pheromones. You put them on our traps and put them near an orchard border. Don't put them in the orchard because you can actually attract the bugs into the orchard. But putting them near the orchard border allows you to monitor them that way. From using these techniques to monitor, 2017, they first come out in mid-May, and then we see a slow kind of progression, and then we have a big peak in mid-July, and then again later in the season. But what's concerning here is that in 2017, we had about 3,700 bugs in our traps, and then in 2018, that jumped up to about almost 12,000. So we're seeing that still that early peak kind of lays off, then get another peak in July, and then later in the season, it just explodes. And then unfortunately, if you're an apple grower, that's pretty much near harvest. So that's a big time we need to be concerned with protecting that fruit from bugs like the brown marmorated stink bug. And this year, I'm not seeing any issues with apples, but we're starting to see some damage in the peaches. So it's something that we need to definitely keep an eye on. Fortunately, we can manage them. A lot of the work's been done up north, like I mentioned, and so there's several insecticides that work great for managing brown marmorated stink bug. The best is really combining neonicotinoids and pyrethroids. So there's 2 very common ones that are already pre-mixed, Bolium Express and Bolium Flexi. And these work really well. They don't have, one's a pyrethroid mixed with a diamide, the other one's a neonic mixed with a diamide, and those work well. Then Indigo is a pyrethroid mixed with a neonic. It's already pre-mixed, and that works well. But also the neonics on their own and the pyrethroids on their own are pretty effective, so you can rotate them to get good control throughout the year. All right, so quickly moving through our spotted lanternfly. It's not actually here yet, but this is an invasive plant hopper. Not actually a fly, as the name implies. Lanternfly, it's actually a plant hopper. Get bigger and bigger, and then later in the summer, so actually pretty slow growing, you get these big nymphs that are red, black, and white. and those become these adults, which cause most of the problems here. And the
Hey, Brett, real quick, we've got one question going back to brown marmorated stink bug, if there's
yes.
a degree day timing.
Brown marmorated?
Yeah, so do we have a degree day timing info for brown marmorated stink bug like we do for scale?
It's not as developed in the South, unfortunately, yet, because they don't only work or develop on temperature like scale does. They also depend on day length. So developing a degree day timing does not work as well for stink bugs because of that day length. It's hard. They're working on it up north to come up with a timing, but it's not ready yet for us.
Okay, cool. Thanks. That was John in Raven County.
Yeah, thank you. That's a great question. Hopefully we'll get there. All right, so spotted lanternfly. Okay, overwinters at eggs. These are laid in the fall, and what's crazy about these egg masses is they blend right into the bark of the trees. And they'll lay these egg masses on rocks, they'll lay them on trees, they'll lay them on people's cars, they'll lay them anywhere, but they're covered in these waxy deposits. They're gray and really blend in, so they're hard to find. And that's what is allowing them really to travel, is that their egg masses are moving across state lines. And so that's something we're really trying to look for, is making sure we don't let those egg masses travel. They have piercing, sucking mouth parts like our stink bugs and our scale. And they feed on the phloem of the woody tissue. So the stink bugs are going to primarily be feeding on the fruit, whereas the lanternflies are actually feeding on the tree, kind of like the scale. And so they don't directly attack the fruit or leaves, which is good, but they feed in these mass aggregations. So all these little lanternflies are feeding, and all that feeding drains the plant. So it's going to reduce that plant health significantly. And similar to the scale, with a lot of that feeding, you eventually are going to have wilting of the leaves, branch or vine death, and with all these big bugs up you're feeding, they're also going to be pooping. So their honeydew is going to be dripping down onto leaves. It can drip down on the fruit, and then you get sooty mold growth. And so then it adds in a whole another problem. Unlike scale, these are pretty big insects, right? So even the nymphs are a little small. They're about ½ centimeter, but the adults are almost 2 centimeters, or almost an inch long with their wings closed. So they're pretty big. So when they're feeding in these mass aggregations, it's pretty startling, and it's not surprising that they can cause severe plant health problems, really resulting in plant death pretty quickly. But we can monitor for them. Fortunately, they seem to prefer tree of heaven. They also feed on grapes, apples, and peaches, which is unfortunate for me, but using tree of heaven, we can find tree of heaven and monitor those plants, because that's where they're going to go first. That's their preferred host plant. They move to the tree of heaven, and then they move to something else. So if we can scout tree of heaven, that'll be our first alarm for whether or not they're here and whether or not they're going to be causing problems. You can also look for these egg masses. They're really hard to see, but it is one way of scouting. And probably an easier way is doing these tree banding. So you can find tree of heaven, put around basically a band of sticky, like tanglefoot, and then go out there and look for whether or not you're seeing those nymphs moving up and down the trees. And that'll give us an idea of whether or not they're here and they're active. Management options. Because this is such a new pest, we really don't have anything labeled for actual commercial or homeowner management of this pest. So I'm going to put up a list of insecticides, but note that these are not legal to use, but they are all very effective. So once we get all the insecticides through the EPA, we do have really good control measures for this pest. All right, so it's a very scary insect that has all these huge aggregations. But once we actually have the insecticides, there's a whole list of things that we can use that are very effective at managing that pest. So really what it comes down to is for bunch grapes, but not insects yet. And then you go in there and it has these diagnostic tools. You can look at the gallery of images of the pest, of the damage, and then kind of goes through the biology, but also almost more importantly, it goes through the insecticides that are labeled for it, goes through both the active ingredients and trade names, their IRAC codes, the efficacy, and then the rates. But it also includes the PHI and the REI, which is really nice. I pull that up all the time because sometimes you forget, how long do I have before I can re-enter? So that's all right there at the tip of your hands. And there's a search function, so you can search for the different chemicals if you don't want to go through all the hassle of finding it through the app. We also have a pesticide risk there, so you can see which insecticides have the most risk for various issues. So here are two examples: pollinator off crop and pollinators in crop. You can see red meaning higher risk, more issues with the pollinators, and then yellow is less risk. So you can try to choose your insecticide based on these environmental categories and their risk factors. It's free. You can download it for both Android and iOS. And if you haven't downloaded it yet, I highly recommend it. It's pretty cool. It's a good tool. And I'm a little biased because I work on it, but in reality, I work on it because I wanted to, because I believe in how awesome it is. And with that, went a little over time, but hopefully we'll have time for some questions.
No, that was great. Thank you so much. So we've got one more question that came in. Are there still 2 IPM guides, SED and SEP? From John.
Oh, for the app? No, so I didn't cover that, but so if you look at our screen, there's 3 original apps. They've all combined into one master app. So if you had the old app, go download the new one. So you just go back into iOS or Android and search for My IPM, and it's the only one there now is just My IPM. Just simple as that.
Yeah, I actually just downloaded it while you were talking. It took like 10 seconds. So.
Awesome. So yeah. One note that because there's a lot of pictures, it can take time to download all those pictures. So if you went through and decided to download all crops, all diseases, all the pests, insect pests, it could take quite a while. But if you select just your peaches and insects, it downloads real fast.
Yeah, this is really cool. All right, does anybody else have any other questions? You can feel free to unmute yourself or type it in the chat and I can read it out. Did I miss anybody? I don't think so. So it looks like we're good. I think that was great. Thank you so much. Definitely appreciated all of the updates for our fruits. Definitely gonna start seeing some of these things, I think, for sure.
Unfortunately, yes.
Especially, hopefully not spotted lanternfly, but we'll get through that. Okay, so keep an eye out for things happening in your counties. Use that app for sure. And just remember Dr. Blaauw as your go-to guy for fruits and pests and things like that. So if nobody has any other questions, this will be archived and Julie Lynn will send out the recorded version. And with that, thank you, Brett. That was really awesome. And we will definitely be spreading this around and using this as a resource.
Sounds great.
All right. Thanks, everybody.
Yeah, thanks, everyone.